resource, then we'll use the resource and finally release the resource. If the resource is not available, then what happens? If we request the resource and it's not available, so what? The request will be denied and the process will be blocked until the resource becomes available. We have seen in chapter 2 some structures that we can use to manage mutual exclusion. And so, if, let's say we have airline reservation system or we have a database with records that need to be updated, then it's up to the programmer to manage these deadlocks. So they will need to use some sort of a structure, mutual exclusion structure, to grant exclusive access to a resource, to a particular process, or to a particular user, or to a particular thread. Some of these resources that we have, some of these structures to manage the mutual exclusion that we have seen was a mutex and a semaphore. There was one of the groups had a project to solve the dining philosopher's problem, and they had to use one of these structures to manage the resources, which were the forks. Because if they didn't do that, the philosophers could get deadlocked, waiting on each other, and none of them will ever eat. So to manage, so we have the same situation with database systems, and our example with the airline reservations. So for some applications, example database, it is up to the programmer or user process to manage the resources. We have seen several structures. One of them was a semaphore that allows exclusive access to a resource at a time, and the other one was a mutex to implement mutual exclusion. So what we can do is create one of these semaphores. So we have a semaphore structure, and we create one semaphore and assign it to a resource that we have to manage. This way we allow exclusive access to that resource. So we would associate a resource with a semaphore. When the process wants to use the resource, the semaphore has two functions, down and up. So if it wants to use it, it will call the down function, then it will use it, and then up to release it. Now, let's see a possible danger with this code. Let's imagine the situation with the two processes. Each one needs two resources, resource 1 and resource 2. So let's say this is the scanner, resource 1, and 2 is the CD recorder, and A needs them and B needs them. A requested the first resource and it was granted. Requested the second resource and it was granted. He used both of them and released them. Next, B comes. Requested the first one, requested the second one, got them, used both of them and released them. Because they requested them in that order. What if we switch the order here? What if B requested resource 2 first? What could happen? So let's switch the order here. B requested resource 2 first, and then resource 1. So let's say both of these processes are running. Process A is running. It came to this line of code where it requested the resource 1, and we switched the CPU to process B. Now B is running. It runs the first line of code. It requests resource 2. And it's granted. And now we switch the CPU and A comes around and runs again. A stopped at this line of code. It has gotten resource 1. The next line of code, it needs to resource 2. It requested. Will it get the resource 2? No, because B got it. So it has to wait. So this process is blocked, it's not runnable. Even if the CPU time comes around, it will not get the CPU because it's waiting on the source. B is still ready, it's not blocked. So CPU time comes around, B stopped at this line of code, runs the next line of code, requests resource 1. Will it get it? No, because A has it. So blocked. It's not in a runnable state. So both of them can get deadlocked like that.